Hello everyone, welcome back to the series on basic electrical and electronics. In this video, we'll dive into a very important topic, potential difference and electromotive force, or EMF. Let's begin. Here's what we'll cover in this session. What is potential difference? What is EMF? The concept of internal resistance of a cell, and the difference between EMF and potential difference. These concepts are essential to understand how real batteries and circuits work. Let's start with potential difference. It is the voltage between 2 points in a circuit. It tells us how much energy is used to move an electric charge from one point to another. We usually measure this across devices like bulbs, resistors, and loads in a circuit. The formula is V is equal to W divided by Q, where V is potential difference in volts, W is the work done, or energy, Q is the charge. So, in simple terms, potential difference is the energy per unit charge used in the external circuit. Now, let's talk about EMF, or electromotive force. EMF is the total energy supplied by a battery or cell per unit charge. This includes the energy required to move the charge inside the battery, even through its internal resistance. Its formula is the same, EMF is equal to W divided by Q, and the unit is also volt, so EMF tells us the total energy per charge, while potential difference tells us the energy used outside the cell. Now here's an important concept. Every real battery or cell has some internal resistance. This resistance is inside the battery. When current flows, some energy is lost due to this internal resistance. So, the voltage available at the terminals is actually less than the EMF dot. This is given by the formula V is equal to EMF I times R, where I is the current, R is the internal resistance of the cell. This is why even a fully charged battery may not deliver full voltage when connected to a load. Let's quickly compare the two. EMF is the total energy per unit charge supplied by the battery. Potential difference is the energy per unit charge used in the external circuit. EMF includes internal resistance losses, but potential difference is what you measure across a device like a resistor. So, EMF is always equal to or more than the terminal voltage. The difference between them is due to internal resistance. And that's it for this video. We learned about potential difference, EMF, the role of internal resistance, and how they all are connected in real-world circuits. If you found this video helpful, please do like, share, and subscribe.